Okay, so let us start with the first mock test for mechanical final. The first question says a hoist drum. Let me move this a bit lower for now. A hoist drum is shown in figure 1, as you can see over here in this figure. A hoist drum is used to lift a load of 1,300 kilograms, all right? So I usually like to write everything down as soon as I read it in the question. So here, mass of the load is equal to 1,300 kilograms with an upward acceleration of 2.19 meters per second squared. So we have an acceleration of 2.19 meters per second squared. What does this mean? This means that in this case, this drawing over here, our acceleration is going upwards like this. As soon as you know your acceleration is going upwards of 2.19 meters per second squared, this means that your inertial force is going downwards. So F is equal to MA. M what? M of the load, all right? The mass of the load. It is going downwards. Tamam? This is, again, the inertial force, yani the reaction force of this acceleration going up. It is what is holding back your weight from going up at that acceleration. By means of a cable wrapped around the drum. The drum has a mass, so M drum is equal to 280 kilograms. A radius of gyration 500, so K is equal to 550 millimeters, which is equal to 0.55 meters. Again, always instantly convert everything to SI units. So this is the mass of the drum and the radius of gyration. And the diameter of 1.2 meters. So you have a diameter of 1.2 meters. معناته our radius is equal to half of that, which is 0.6 meters. تمام? If the friction torque at the bearing is equivalent to 1.4 kilonewton meter, معناته torque friction, زين, I usually write it as TF, is going to be equal to 1.4 kilonewton meter. What does this mean? It is 1,400 Newton meters. Make sure from the very beginning you're always converting your units to standard form. All right? Attempt the following questions. The first thing it says, draw the free body diagram showing all the forces and the directions. So how will you draw the free body diagram? You're going to have a free body diagram for your drum, and you're going to have a free body diagram for your load. So I'm going to do them together over here in this case. So we have our load over here. زين. Let me make it a bit more neater عشان يكون مرتب من البداية. Alright, so we have our load here. This is ML. Alright, and this is our drum over here with this specific radius. Alright, so how would you draw the free body diagram? So the first thing we know is we have acceleration going upwards. So we know that acceleration A is equal to, it was 2.19 meters per second. All right. And that means that on our load, we're going to have a force downwards on it. You can draw it on top of it directly if you'd like as well, to be more neat, يعني. F load, which is ML A. This is the force due to, or the inertial force due to acceleration. And then, obviously, the load itself is going to have a weight. So if I move this a bit here, you're going to have the weight of the load as well. So I'll call this W, which is equal to ML, the mass of the load, times gravity. All right? And then you're going to have a tension force over here, which we usually call E. All right? So this is what it will look like for your block. This is just for your the mass or the load, yani. This is your free body diagram for the load. How about the drum? So this tension E, if it's going upwards here, every force has an equal and opposite reaction. Yani every action has an equal and opposite reaction. Newton's third law. So the same value of E is going to be in a downwards direction when we're looking at it from the perspective of the drum. And since acceleration is going up, زين, what does this mean? إذا الحين احنا عندنا acceleration is going up. معناته this block is going upwards. And if we're going up over here, معناته this drum is going in this direction. يعني it is accelerating in this direction. Therefore, we can say our acceleration, angular acceleration alpha, is in this direction, meaning our torque as well, T, is going to be in this direction. This is always the case where your acceleration is in the same direction as your torque. And because our torque is going into this direction, we're going to have the resistive force inside in this way. Let me actually use a color for this as well. Let's keep it as brown. All right. So this is our frictional torque. What does this frictional torque do? It is opposing the motion. لأن our torque is going counterclockwise, معناته our frictional torque is clockwise. Okay. What else do we have? Due to this acceleration over here, we're going to have an inertial force or an inertial torque, I should say, in the opposite direction, known as I alpha. All right, where I is your moment of inertia, your polar moment of inertia. تمام? And this is it. This is your total, your full free body diagram for both cases. Let us just add a few points here for solving. So we know that our radius is over here, which is equal to 0.6 meters. And let's call this point in the middle point O. All right. And this is it. This is how you would draw a free body diagram for such a case. Okay. Why is E not downward? Again, it depends on the perspective. إذا احنا we're looking at it from this direction, and then a tension force. This E is pulling up on this load. فمعناته in this, for analyzing only this block, then our tension force is upward. When we go look at it just from the drum point of view, this is going to be how it looks like. There's going to be a tension force downwards. لأن the block is pulling on this from the bottom. معناته بيكون عندنا a torque. All right, if you want, we can mention the torque as well, or the moment due to this. We're going to have also a moment in this direction, which is equal to E times the radius. All right, remember, moment is just force times perpendicular distance. So when we're looking at it this way, if we have a torque that is going to, or a force that is pointing downwards at this, معناته about the point O, all right, it is doing a motion or a moment that is clockwise. That is why this ER is clockwise. And why did we multiply it by R? Because we're doing it about O. So the perpendicular distance is this distance over here, right? That is why we are multiplying it with R. Okay. So now let's see what the second question. Once this was part I, all right, I'm just gonna select all of this and copy it and then reduce its size later on so that we can use it again. So for part I, we are done of drawing the free body diagram. Part double I says calculate the torque required at the drum. ليش IA مع TF؟ I alpha is always going to be in the same direction as TF, always. لأن this is, think of it this way. This friction over here, and then TF, this friction over here, is due to the bearing اللي في النص. إنزين لأن عندنا شيء يدور, okay? So we're going to have friction at the bearing في النص. إذا هذا قاعد يدور بأي اتجاه، إنزين بيكون في friction في الاتجاه عكسه. So this is our TF من وراء البيرنج هني، يعني بيكون في احتكاك في النص. Alright? This is for TF. I alpha is due to the acceleration. لأن this is accelerating in this way, the weight of this drum, the actual weight of this drum, is trying to resist the motion. So that is going to be in the opposite direction, which is known as I alpha. And then this is similar to MA in terms of linear motion. but for angular it is going to be I alpha, where I is your moment of inertia. So this is basically just always opposing your acceleration, your angular acceleration, and it will always be in the same direction in these cases with your TF, لأن your angular acceleration most of the time is with the same direction as your torque. تمام? That is why this is the case. One is negative, we're going to look at that in a bit. So let's look at part B. They want us to calculate the torque required, which is this torque T, the blue torque required at the drum. How are we going to do this? So for part I, then before we even move on to the torque, then let's look at the values that we have and the values that we don't have in this drawing over here, or this free body diagram. So we have the mass of the load. All right, again, reminder, mass of the load is equal to 1,300 kilograms. We have acceleration, 2.19, written over here. We have our weight, which is ml times g. We have the mass of the load, so we can calculate that. We have our radius. We have TF was given to us as well in the question. And the frictional torque اللي هو TF هني اللي هو 1400 نيوتن متر. 1400, can 1400, yeah, Newton meter. But what is remaining? So the torque is what we need to find T, that we will calculate. We do not have our I alpha and we do not have our E. First, let us look at I alpha. Tamam? I alpha, what does that mean? So we need to find our I and we need to find our alpha. I, the moment of inertia, is always going to be equal to the mass of the drum times the radius of gyration squared. This is just a formula you guys need to know. I'm not sure if this is given in the formula sheet. If it is, then it's easy. But this is always going to be the case for your moment of inertia. It is the mass of the drum. The mass of the drum, which was given to us, MD, right? Which was given to us as, I'm just going to copy paste this down actually. So MD, which was given to us, I believe, was 280 kilograms, yes. And our radius of gyration, K, which was given to us as 550 millimeter or 0.55 meter. So the only point of these two values is to determine your moment of inertia. So this will be equal to MD is 280 times our radius of gyration squared, اللي هو 0.55 squared. Okay, so I is going to be equal to 84.7 kilogram meter squared. Why is this the unit? Because we're multiplying a kilogram, اللي هو mass, with a distance 0.55 meter, and we're squaring it. That's why it's kilogram meter squared. All right. This is for I. What about alpha? What about alpha? We know that before even writing alpha, we know that acceleration is equal to angular acceleration times the radius. Okay? معناته our alpha is going to be equal to acceleration divided by the radius. And the radius we have already found to be 0.6 meters. And then هو radius of the drum. So we can simply find our alpha, which is 2.19 divided by 0.6. معناته our alpha is going to be equal to 3.65 radians per second squared. So 3.65 radians per second squared. Remember, the units is radians per second for angular acceleration, radians per second squared for angular acceleration. Okay? So now we can find our I alpha. Our I alpha, we can multiply them and find it together. If you want, you can do it in one step here, but I prefer doing it later on in the equation. All right? So we have found our I over here, and we have found our alpha over here. Okay? Now, what else do we not have? We do not have now our force E. Okay? How can we find our force E? Our force E, we're going to have to do our sigma F for the bottom part. So now we are only going to be looking at this part of the drawing اللي هو اللوج اللي هو sorry load. All right. فاللود عندنا اياه Then if I just draw it really quickly again, just the load, we're going to have weight going over here. This is W equal to mlg. We have our inertial force over here اللي هو F equal MLA. And then we're going to have our tension E. Then our tension over here E. Okay, we just apply sigma Fx, or sigma in this case Fy equal 0. Sigma Fy equal 0 معناته sigma Fy equal 0. What is our sigma Fy? Let us take our upwards as our positive direction. معناته we have E minus F minus W is equal to 0. زين؟ sigma forces in Y نفس ما كنا نسوي قبل. Okay? So now we can find our value for E because we can find F and W. So E is going to be equal to F plus W. تمام؟ معناته E is equal to, what is the F? F is MLA, and what is W? MLG. And we have all the values here. We have the mass of the load, we have the acceleration, and we all know what the acceleration due to gravity is. So our value for E is going to be equal to, the mass of the load is 1,300 kilograms, times our acceleration, which is 2.19 meters per second, plus the mass of the load, which is 1,300 kilograms, times acceleration due to gravity, which is 9.81. So now we can find the value of E by just putting all of this into the calculator. We will get that E is equal to 15,600 newtons. So now we have found E. Why did we need to find E? Because again, we are trying to find E times R because we want to find our torque. How can we find torque? Torque is a moment, or it is using a moment equation. So let us look at the top part now by itself, just the top part. So if I just take this part and take it to the bottom over here, let us just look at this part over here. زين? So we are going to take our sum of moments about point O, اللي هو center, is equal to 0. And we are going to assume counterclockwise to be our positive direction. It doesn't matter what you assume is your positive, just stick with it and solve, and your values will all be sorted out automatically. And then just assume a direction and solve with it. So in this case, I assumed counterclockwise to be my positive. معناته our torque, which is counterclockwise, is equal to, remember alpha, this isn't a moment, this is just the acceleration. All right, this isn't an actual moment, you're not putting it in your equation. What is a moment is I alpha. Similar to the earlier case over here, we had acceleration, but we don't put it in our forces equation. What we put is the force F, which is equal to MLA. Tamam? So it's the same case over here. So the torque minus our frictional torque, because frictional torque is a clockwise, minus I alpha, because it's also clockwise, minus E times R. Okay, so E times R is equal to 0. Again, because these are all clockwise except our torque, which is counterclockwise. And now we can just plug in our values, but first let us rearrange the equation to solve for T, which is the torque, because it is equal to TF plus I alpha plus E times R. And then for our torque is going to be equal to, what is the value of TF that we had? The value of TF given in the question actually is 1400 Newton meter. So 1400 Newton meter plus I times alpha. I we have already found, and alpha we found. I was 84.7 and alpha is 3.65. So 84.7 and 3.65 plus E times R. We just already have found our E. Our E is 15,600 newtons. times the perpendicular distance r اللي هو radius, which is 0.6 meters. And now you can find your torque, T. T is equal to, you just add up all these values, and you're going to find out that your torque is going to be equal to 10848.35 Newton meter. And this is how you solve for this part of the question. Part 3, by the way, it just says find the tension in the cable. In part 3, we have already done it. We had to do it to find our torque. This is our tension in the cable. Remember, the tension in the cable is E. We have mentioned it to be E. So for part 3, it is simply E is equal to 15,600 newtons. All right, this is our tension in the cable. Before I move on, anyone has any questions about what I have done? Is this clear? فهمتوا أنا كيف حصلت كل شيء؟ Good. زين. Let us look at the last part of this question اللي هو determine the angular velocity of the drum after 10 seconds if the system starts from rest. For the most important thing you need to know here is we are given a time. For here we are given t is equal to 10 seconds, and we are given here that the system starts from rest, meaning our initial angular velocity is equal to 0. It is mentioned in the question. So this is very simply just, so for part IV, we were given that t is equal to 10 seconds and omega 0 is equal to 0 radians per second, اللي هو initial angular velocity. What do we need to find? We need to find our omega, our final angular velocity. The equation is similar to the linear equation, which is omega is equal to omega 0 plus alpha t. I believe this is also given to you guys in your formula sheet. So you just plug in your values. Omega is equal to omega 0 is 0 plus alpha. Alpha is the value that we have found early on, the same alpha. This is your angular acceleration, which is 3.65 times the time, which is 10 seconds given in the question. معناته omega is simply equal to 36.5 radians per second. And we have solved the entire first question. تمام? Anyone has any questions about this? لو كان الاكسلريشن على تحت الاي حقت الدرام بتكون على اي اتجاه؟ يعني قصدك هني لو الاكسلريشن تحت ما بيتغير نفس الاتجاه. لأن if you think about it you still have tension in the rope. يعني للحين في ضغط، في شيء قاعد يسحبه من فوق، انزين، وهني على الدرم للحين قاعد يسحبه على تحت. شو اللي بيتغير؟ الدايركشن of F. F is now going to be upwards لأن F is dependent on this acceleration. إذا أنت قاعد تسحب واير من الصوبين، لو قاعد تحركه يمين أو يسار للحين في tension in the rope in the same direction، للحين في سحبة على اللاين نفسه. So acceleration does not affect the direction of tension as long as this string is taut اللي هو بما معناه يعني in tension، يعني أكيد في سحبة عليه, which will always be the case in our situation. So it will always be in the same direction. تمام؟ E is not scalar. E is a vector. These are all vectors. We're dealing with forces. Forces are all vectors, but E's direction will not be affected. It has a direction. I'm not saying there's no direction, but it is not affected by the direction of acceleration. That's what I mean. That's all I said. It is a vector quantity. All of these are vector quantities we're dealing with. You could say radius is scalar, yes, but when we're dealing with forces and acceleration, everything is a vector quantity. All right. Let's move on to the next question. If anyone doesn't have any question, we can move on. Insane. I will do a quick recap of this question from the very beginning, so you guys just understand what has happened. All right. So they gave us all these values. They gave us the mass of the load, the acceleration, which is upwards. When you know that acceleration is upwards, معناته the force, inertial force on this load is going to be downwards. Insane. So that is what you know when you are given direction of acceleration, this force direction. تمام? And it will be always opposite to where the acceleration is. Then we were given the friction, so we have friction for torque. We also have been given the mass of the drum. we have been given the radius of gyration. The point of the mass of the drum and radius of gyration is just to find your inertia. That's the only point of them in the question. You will not use them for anything else. All right. Then you're given the diameter of the drum. معناته you should find your radius because you're going to be using your radius, not your diameter in solving. And then that's it. So to draw your free body diagram, once you know where the direction of your acceleration is, you're going to know that this is going in that direction. معناته this has to rotate in this direction. So you will know where your direction of motion is and your angular motion is. معناته your angular acceleration is going to be, in this case, counterclockwise. All right. And your torque is going to be also in the same direction because you're trying to lift this to go up. معناته there has to be a torque in the same direction as motion. Your frictional torque is going to be opposite to the direction of your actual torque. And your I alpha will also be in the opposite direction of your torque, or I should say of your acceleration. تمام? So your I alpha is just your inertial force to stop the acceleration from happening. That's all it is. And then you're going to have tension in the cable as well. This tension is going to be upwards, and from the perspective of the block, from the bottom free body diagram, it's going to be upwards as it is pulling it up. From the drum, it will look like a force that is pulling the drum down because every action has an equal and opposite reaction, which is just simply Newton's law. So therefore, you're going to have it downwards for this system and upwards for the bottom system. And this will also cause a torque moment over here, a moment, sorry, not a torque, a moment on this. And the way you can find the value of this is by multiplying by your perpendicular distance, which is your radius from point O, from the center of the drum. So once we find our values, then once we find our values, you can find your I, like I said, using the equation of mass times radius of gyration. And you can find your acceleration, your angular acceleration from this equation, which is acceleration is equal to alpha r. So alpha is just the acceleration divided by the radius. All right. Once you find your I and your alpha, then you can start solving for the question. You need to find the tension in your spring, or the tension in your in your cable or line or wire. Just 1 second, 1 second. I'll be right back. 1 second. I'm sorry about this. Assalamu alaikum. I'm very sorry about that. I hope most of you are still around. شوية خيست الله يعين. انزين. Let's get back to it. Again, I'm really sorry about that. Unfortunate thing. ترى هو نفس البايب اللي انفجر اللي خلاني أأخر أسوي بسبون هذا وبعد ما الرد ضرب عندي ما أدري إيش سالفته. المهم, let's get back to our actual topic. So as I was saying earlier, احنا we are looking at, when we're looking at this drum, we're going to have an acceleration over here. This acceleration is going to make us understand if it's going upwards, معناته that the acceleration of this is going to be going into a clockwise direction. That means our torque is going to also be going into a, counterclockwise, and our torque will also be in a counterclockwise with torque friction, and I alpha will always be opposite to these two in direction. Then we're also going to have a moment due to the tension over here. And that's also going to be coming into our equation when we are trying to find the torque. We find our E by looking at the bottom equation by itself, and then we're going to have our ML times A, we can find that value, and we have our ML times G, which is the weight, and we can find that value. Once we find these two values, we can just do our sigma Fy equation, and you'll find that E is going upwards and F and W are going in the opposite direction, so they're negative. Manata, we just then plug in our values and find E. Same thing now for the torque, but we're going to be using our sigma moment equation, moment about 0. All right, so the moment about O or 0 or whatever, we're going to take it and we're going to assume a positive direction. In this case, we could assume the counterclockwise as positive. Therefore, your torque is going to have our positive sign, and everything else will have a negative value because they're all going in a clockwise direction. So your TF, your I alpha, and your E times R. All right. Once you do all of that, multiply, add them all together, you just plug in all your values that we have found early on. If you got 11,000, it's fine. It is just the values of numbers that you might have يعني عوضت يمكن غلط بعد. Just double check your calculations, make sure it's correct. But it's fine. If it's close to 10,800, معناتها it is close enough. You might have يعني skipped a decimal مثلا, you put 3.7 here instead of 3.65 or something like that. It's totally okay as long as the value is reasonably correct and your steps are correct. Once you find your torque, question 3 was simple. It said just find tension, which we already did. You find tension over here. And okay, maybe I did something wrong in my calculation. Let me just double check. 84.7 times 3.65 plus 15,600 times 0.6. Oh, yep, you guys are correct. 4.7, 3.65, 15,600. Yeah, you guys are correct. My bad. I just copy pasted wrong. I've already solved this before and I actually got the right answer last time, but I don't know why I put this number instead. So it's 11,069.155 Newton meter. Thank you for that. Again, it's just a calculation error. It's not even a calculation error, it's a copying error. Just the steps is the same. This is just the actual answer for this. This is your tension. And when they talk about angular angular velocity, you're going to be using this equation. Even if they were asking for angular displacement, just as an example, if they were asking for your theta, your angular displacement, what is it equal to? You can use your equations that you know, the equations of linear and all of that, that is going to be most probably provided to you in your exam. Not linear, but angular, which for displacement, there's two of them. There is one that is omega plus omega 0 over 2 times t. You can use this equation since you have found omega. And then there is one, which is, I believe, ut plus half at alpha t squared. Not u, omega 0 plus half omega 0 t squared. So if they were asking for the angular displacement of it, you can apply these equations instead, and you will be able to find not omega 0 alpha. and you'll be able to find your angular displacement as well. As long as they give you time, you will be able to find any other value that you want, and as long as they give you one extra variable, for example, they give you either initial or final angular, you'll be able to solve everything because your alpha is the same one that we have calculated early on over here. Let's move on to the next question. I'm pretty sure everyone has a good idea of how this question is solved now. Let's look at the next question that we have in our mock exam. So, a 3-kilogram crate slides down a ramp. The ramp is 1 meter in length and inclined at an 30-degree angle, and it is shown here in the picture anyways. So you have a ramp where you have a box on the ramp. It is falling off, right, starting from this point, ending at this point. The distance it covers is 1 meter and inclined at 30 degrees. The crate starts from the rest at the top and experiences a constant friction force F. So there is a friction force. There is friction. We're not neglecting friction in this case. If the speed of the crate at the bottom of the ramp is 2.54 meters per second, answer the following. So before anything, let us understand what we have over here. And then let us look at this a bit bigger. So over here, we have our first phase. And then let's call this phase 1. Phase 1, we have velocity 1 equal 0. All right? Or our initial velocity, you can say, is 0 because it starts from rest at the top. And our height 1 is equal to 0.5 meters because this is at 0.5 meters from the ground. Okay? At position 2 now, when we reach the second stage, we have V2 is equal to 2.54 meters per second, as said in the question. It says, crate at the bottom of the ramp is the velocity of it, or the speed is 2.54 meters per second. And our height 2 is now equal to 0 meters. Tamam? So we have our phase 1, we have our velocity and height of phase 1 and velocity of height of phase 2, so we can find our energies up and down. Before that, let's see what the equation wants. It says draw the free body diagram of the crate, showing all forces and their directions. So if we want to draw that free body diagram, yes, this session is recorded. So if you want to draw that free body diagram, it's going to look something like this. So you have your angle theta over here, which is given. You're going to have your block laying on this. You're going to have your gravity, which is always downwards. So gravity is going to be going over here. And you're going to have gravity split into two components in this case, because we want it to be aligned with the direction. So you're going to have this as your W, which is equal to mg. This is, let me make this a bit bigger. Okay, so you're going to have your W, which is equal to mg. You're going to have your Wx over here and your Wy, which is your weight components, because this is at an angle. And since the motion is going in this way, direction of motion, all right, you're going to have your friction force going in the opposite direction like this. So you have a friction force I'll call Fr, and we have a normal force that is perpendicular going like that with our block. Okay, let me just draw the block a bit more neater. So this is what it will look like. Okay, this is your free body diagram. Tamam? That's it. You draw this, you get 3 marks for your first point, for your first part. Just know how to properly draw it from the beginning. Because there was friction mentioned, remember to put it. And of course, your normal force, don't forget it when it's on a flat surface. Now, part 2 says use energy methods to determine our friction force F. What does this mean? So first of all, how can we determine our friction force F? We can either find it by mu times n, but we are not given the coefficient of friction, so we cannot use that method. What is another method? They even mentioned it, the energy methods. So what energy methods do we have? So first of all, how can we find the energy that is exerted because of friction? Yani the energy due to friction, how can we find it? So the way to do that is we need to find the work done by friction. In other words, it is equal to the friction force Fr times the distance it has moved. And in the question, they have given us that the distance, the ramp is 1 meter in length. So the distance we have is 1 meter, all right? So distance is equal to 1 meter. So we already have the distance, but we do not have the friction or the work done, so we can find the friction, which is what we are trying to find. So what is another way of finding friction, work done? Remember that work done is basically energy, all right? So another way is by looking at our two phases over here, our phase 1 and our phase 2. So let me copy paste this down here, make it a bit smaller. So we're going to have energy at the beginning and we're going to have energy at the bottom. And there's going to be energy loss, all right? So there will be energy loss. Let me write that in black. Energy loss due to friction. All right, so we're going to have energy loss due to friction. And this energy loss is equal to the work done by friction. All right, this is the same energy. So the energy loss due to friction is the same as the work done because of friction. All right, so how can we find this energy loss due to friction? Remember that energy loss is simply the change of energy. I'm going to call it TE, which is total energy, is equal to the total energy at one point, which is at point 2, minus the final point, minus the total energy at point 1. So the final point minus the initial point. Remember that this is the change in energy, not the loss. If we get this as a negative value, that means we have a loss of energy. All right. So how can we find the total energy at these 2 points? Very simply, for V1, all right, let me put it actually over here. So TE1 is equal to the total energy of 1 is going to be equal to the potential energy at 1 plus the kinetic energy at 1. Since our velocity is 0 at 1, our kinetic energy is going to be 0. Since we have a height, that means we have a potential energy. So total energy at 1 is equal to mgh1, which is the mass, which is 3 kilograms times 9.81 times the height of 0.5. Right? This is the total energy at point 1. So if you just calculate this, total energy 1 is equal to 3 times 9.81 times 0.5, which is 14.715 joules. All right? Very simple, very straightforward. Just apply your energy equations. So this is for point 1. What about point 2? Now let's look at point 2. So the total energy 2 is equal to, let me make this a bit smaller over here. Then, so total energy 2 now is equal to the potential energy at 2 plus the kinetic energy at 2. Then, so total energy at 2 is equal to, what is the potential energy at 2? It is 0 because the height is 0. And we have a velocity, so we're going to have a kinetic, a component of kinetic energy, which is half mv2 squared, or in other words, half the mass of 3 times the velocity to 2.54 squared. معناتها total energy 2 is equal to half times 3 times 2.54 squared is equal to 9.6774 joules. So now we have found our TE2 and we have found our TE1, and we can just simply plug them into here. This is our TE2 and this is our TE1. So the change of energy of total energy is going to be equal to 9.6774 minus 14.715. If you notice here, you will get a negative value, and this is going to be minus 5.0376 joules. Remember, what does this minus basically means? It just says that this is an energy loss. So if you want to reword it, you can say that the energy lost, so TE, the total energy lost, is equal to 5.0376 joules. All right? Yeah, and that's basically it. So now we have found our total energy lost. All right. However, we want to find our friction. So this total energy loss is equal to the work done by friction. So we can plug it in to the equation over here. So we can say that total energy loss is equal to the work done by friction, which is equal to the friction force times the distance. معناته we can solve now for the friction force. It is equal to TE loss over the distance covered, which is 5.0376 divided by the distance covered, which was 1 meter. معناته our friction is equal to 5.0376 newtons. And we have found the force of friction. Is PE the weight on the x-axis? PE is the potential energy. Potential energy is just the y. There is no x-axis for PE. PE is simply just the height, the change of height. That is what potential energy is. MGH, all right? That is what potential energy is. Kinetic energy is half mv squared, and potential energy is just dependent on height. So if you have a height, you have potential energy. If you have a velocity, you're going to have kinetic energy, all right? Okay, so let's look at what the next part of the question wants. The last part says, how far does the crate slide before stopping on the horizontal floor if it continues to experience the same friction force? So our FF that we found, it is the same friction force, but they want us to know how far the crate slides. معناته we need to find the distance. We're going to call it the capital D. And then before stopping, معناته our last velocity, we'll call V3, is going to be equal to 0. معناته it's going to stop. So if we draw this, to look at this in a figure, now our block is at the bottom. زين? It's at the bottom. And we want it to reach a point, it's going to reach a point where it will stop. And the distance over here, this is our distance D. Okay? So this was, if you remember from here, this was our point 2 from early on, where it reaches the floor. So this is the same thing as earlier. This is point 2, where we had a velocity of 2. What was it? 2.54? 2.54 meters per second. And this we'll call point 3, where our final velocity v3 is equal to 0 meters per second, because it has come to a stop. تمام? This is v2, and that is v3. And we are going to be applying the same exact, KE is kinetic energy, which is half mv squared. We are going to be applying the exact same equation that we have applied up before here, which is the work done due to friction, which is equal to the total loss, is equal to friction times distance, but we need to find our distance. So again, we need to apply this equation, which is TE loss is going to be equal to our friction force times this new distance D for between these two phases. So how do we do that? Again, the same exact idea. Delta TE is going to be equal to TE final. In this case, we have TE3 minus TE2 initial. And then remember, this is TE2. This TE2 is exactly the same TE2 we found early on, which is this TE2, the exact same value, the exact same way of calculation as well. And this is our new TE3. What is the value for TE3? If we look at it here, we don't have any change of height or anything. So our H here is still equal 0. All right, H3, also H2 from previously, it was equal to 0. There's no change in height. All right. So the potential of it, so let's write the equation fully first. So TE3 is equal to TE3 is equal to potential energy of 3 plus kinetic energy of 3. However, since H3 is equal to 0, we have no height, so there's no potential energy. And velocity is also equal to 0, so we have no kinetic energy. So the total energy in this phase is just simply 0. Then we have no height and we have no kinetic energy. So it's just 0 joules. تمام. Since it is 0 joules, that's it. We can now solve for our change in energy and total energy, which is 0 minus our TE from previously, the same value, which is 9.6774. 9.6774. معناته delta TE, the change, is equal to minus 9.6774 joules. All right? Which makes sense. ليش? Why is this going to be negative and why is this 0? لأن there's going to be a loss of energy. لأن this is getting stopped due to the force of friction. The only thing stopping this is there's a force of friction being applied to it, which is slowing it down. That's why there's going to be a loss of a value, of a specific value, until the energy is 0. Then it's not moving. The block is not moving. It will have no energy in it. This is our change in energy, in total energy. So TE loss is simply just 9.6774 joules. And now we just plug it into this equation. The only difference is we are using this equation over here to find the new distance. So we can say the new distance is going to be equal to TE loss divided by the friction value that we have found earlier. So D is going to be equal to TE loss is 9.6774 over the friction value that we have found, which is 5.0376. Therefore, our distance is equal to 1.921 meters. Kinetic energy, is it clear? Potential energy, is it clear? Again, KE is kinetic energy, which is half mv squared. PE is potential energy, which is mgh. Potential energy is dependent on height. Yani if you have a height, you're going to have potential energy. If your height is 0, you're not going to have potential energy. And for kinetic energy, if you have a velocity, then you have kinetic energy. If you do not have velocity, then you're not going to have kinetic energy, which is half mv squared. Tamam? And that's pretty much it. Remember that the change of energy is basically just final energy minus initial. When you get a negative value for a change of energy, معناته you have a loss. All right. So you can remove the negative and just mention that this is the loss of energy. All right. And just keep it as a positive value. And the loss of energy is the same as the work done due to the friction force in this case. So because TE loss, since energy is simply just the work done, we also know that work done, the rule of it is it's the force times the distance it is moving, or the distance it is being applied for. So in this case, in the first case, our distance was given as 1 meter. We can simply find our friction force directly. In the second case, the question asked, to read it exactly, how far does the crate slide before stopping? يعني في النهاية it will reach 0. زين. On the horizontal floor if it continues to experience the same friction force. يعني the friction force did not change. They are assuming that there's going to be the same amount of friction applied on the box. So the friction is going to slow it down until it eventually stops. So they want us to find when it stops. How do we do that? First, we look at the phase before that. يعني when it reaches the ground, which is here, phase 2. This is when it starts from the ground. So this is our new initial phase. Initially, we had a velocity of 2.54 meters per second. Obviously, there's no height here. And again, in the last phase, when it comes to a complete stop, معناته ما في velocity. خلاص وقفت الصندوقة. Did not change any height, so our height is also equal to 0. Therefore, our total energy at the end is going to be 0 because there's no potential energy or kinetic energy. فبيبقى لنا TE3 minus TE2, which is just the same exact thing we did earlier, which is the change of energy. But now the work done by friction is on a new distance because we are determining it between 2 and 3. And this is for a new distance D between these two. All right. This distance over here is going to be was what we need to find. And obviously, since we are dealing with SI units, this distance is going to be found in meters. So simply, we find our TE loss by doing final minus initial in terms of energy. So it's 0 minus 9.6774, which is the energy here, which is the same energy we found early on from this part, okay? The same energy. So it is going to become a negative value again, which makes sense because it is a loss of energy. لأن عندنا loss, we can just put it as a positive value and mention that it is loss. And this will be equal to your friction force times your distance. Rearrange the equation and you will substitute your values and find your distance D. تمام? At the end, the unit is meters. Yes, this is in meters because we are using SI units. This is in joules and this is in newtons. All right, so your value is going to come out in meters. Let's move on because we're running a bit out of time. So let's move on to our impulse question. Over here. So actually, let's look at this and analyze it using this image that they gave to us. So a 355 kilogram spacecraft slash satellite is moving at a speed of 6,000 meters per second. So we are going to call this our mass total is equal to 355 kilograms. And we're going to call this our initial velocity u, which is equal to 6,000 meters per second. All right. So we have an initial velocity, an initial mass, because this is one mass before separation that will separate. When an explosive charge given a thrust of 1,500 newtons. What is this? This is your thrust force. معناته when it explodes, you're going to have a force F over here that is being applied to the left on the spacecraft and to the right on the satellite. You are separating them. An explosion will cause a separation. فواحد بيروح صوب واحد تاني بيروح صوب الثاني, or the force applied is going to apply a force on both. All right? So that is what your thrust force is. It basically causes this impulse to separate these two entities. All right? Separates off 225 kilogram satellite. So we're going to call this our MB. All right. Let's use the color purple. All right. So this is MB, which is equal to 225 kilograms. All right. Which is propelled ahead of the launching spacecraft in the line. Meaning what? Meaning that it is moving in the same direction as the initial spacecraft. All right, this is what it means by propelled ahead. The speed of the spacecraft falls to 5,980 meters per second. معناته شو الحين؟ معناته we have our V, I will call this A of the spacecraft, is equal to 5,980 meters per second. And this is a positive value. Why? لأن they didn't say that the spacecraft went into the opposite direction. They just said that it slowed down. معناتها خفت السرعة من 6000 صارت ل 5980. Okay, that's all it did. It slowed down, but in the same direction. Same thing about the propelled ahead means the velocity VB. All right, let me write VA over here. And the velocity VB is equal to some velocity, but we know it is in the same direction. We know that the velocity VB is in this direction, and this is the velocity of VA. All right? So, find the duration of the thrust. Before I even get into the thrust, let's analyze what we have. So we had an M total over here. The total mass of the payload or the spacecraft with the satellite is 355 kilograms. The satellite is 225 kilograms. What will be the mass of the spacecraft? Yes, it is given here 130, but how do you get this if it was not given? M total. So with the mass of the spacecraft, we're going to call MA. And M total is equal to the mass of the spacecraft plus the mass of the satellite, اللي هو MB. All right? So in other words, 355 kilograms is equal to MA, which we want to find, plus 225. The reason I'm doing this is not all the time they will give you both masses. You need to make sure you know how to get your final masses. So if you do this calculation, you will find out that MA is equal to 355 minus 225, which is 130 kilograms. All right. Tamam? So here we have somewhat of a similar case to what we usually see before, where we have them, usually they would be separated and they will combine, but in this case they start combined and then they are separating. Okay, so now the mass, initial mass, is the total mass of both of these two together. That's why we can find ma. And as well, the initial velocity here is the initial velocity of both of these um, rocket, spacecraft, and satellite. لأن they were both moving at the same speed initially because they were moving as one object. When they separated, their velocities have changed. So the spacecraft has been reduced, but in the same direction, the satellite has been propelled forward, means pushed forward. تمام? So now that we have done our analysis, let us see what the question wants. Find the duration of the thrust, meaning they're talking about this thrust force. Find how much time it took for this thrust force to occur. All right. What is this equation? So for I, remember that impulse momentum equation, which is F times T, your thrust force times time, is equal to mv minus u. All right. Now, when we're talking about thrust, what m are we talking about? What v are we talking about? What u? Let's look at it this way. When we talk about thrust, we're talking about after the impulse has occurred. So we're not looking at the mass before, we are looking at the mass after. And we can find it by using either VB or VA. However, because we don't have VB and we have VA, we need to look at the spacecraft's data. All right. So again, you can either say F times T is equal to MB VB minus U, or you can say F times T is equal to MA VA minus U. All right. You can use either one. And our U, like I said earlier, is the same for both because they were both one piece in this case. So U is equal to UA and UB, our initial velocity. All right. U. Okay. But because we don't have VB, we do not have this value VB over here, we cannot use this equation because we have two unknowns. Because remember, we are trying to find our time t, right? But here we do have our VA and we have our U as well. We have our mass and we have our thrust force. So we can simply just use this equation to solve. Yani if I rearrange equation 2, so I have equation 1, equation 2, we can use equation 2 to solve. Rearranging it, we're going to have MA VA minus U divided by force F, and we just plug in our values. The mass of A is 130 kilograms times VA, when el VA? VA is 5980, which was given in the question. 80 minus 6,000, which was also given in the question, our initial velocity over here, over. Now, remember, we are dealing with vector values, so the value of F, the magnitude of it is given to us to be the thrust force ما كتبنا مكان هنا. So F is equal to 1,500 newtons. All right. So we know that the value of it is 1,500 newtons. However, we are looking at which system? We're looking at the spacecraft system. The force is acting opposite to the direction of the velocity. إنزين? So if we are assuming this to be our positive direction, because this is the velocity direction, we took it as a positive value, the force is acting on the opposite direction of the velocity. معناته when we are considering this system, our F is a negative value. All right? So let me actually write this down. So F here is minus 1,500 newtons. And when we're looking at the satellite system, the impulse is now in the direction of the velocity. So F over here, it's the same thrust force. It is just the sign that will be different. It is 1,500 newtons. Since we are using this system to determine our time for impulse, معناته we have to put our negative sign because our force is negative in this case. تمام? So this is the idea. Once we plug in all our values, we're going to find out that our time is equal to 1.73 seconds. Okay? And that's pretty much it for the time. Let's look at the next part. Find the final velocity of the satellite, which is VB. Again, very simple. All you're going to be doing is you're going to be applying your conservation of momentum equation. Actually, there are two ways to solve this. You can either use the conservation of momentum or you can use your impulse momentum equation as well. But I prefer using conservation of momentum as it is just a much simpler concept to apply or a much straightforward concept to apply in my case, but they're both correct, all right? The reason I want to do it using this is I want to show you how you would apply conservation of momentum. What does the conservation of momentum tell us? It tells us before is going to be equal to after. That's what any conservation means. معناته anything before equal after. In this case, we're talking about the momentum before is going to be equal to the momentum after. معناته our M total. So before we had our M total and we had our U, right? This is before. Our before separation, we just had M total and we had U. So M total times U is going to be equal to. Now let's look at after. What do we have after? We have MA times VA. So MA VA plus we have our MB and VB, which is the separation of the satellite from the spacecraft. And then our MA and our MB, MA times VA, and our MB times VB. And we have all of these values except for VB, and we can just simply solve. So our mass before the mass total, all right, so the total mass is 355 kilograms. So 355 kilograms times U, which is our initial velocity of 6,000 meters per second, is equal to our mass A that we have found earlier, which is 130 kilograms, times our velocity A, which was 5,980 meters per second, plus 225, which is our mass B, times VB, which we want to find. All right. And that's it. Now we only have one unknown. We solve for VB, simplify this equation, and we find the value. So when we multiply these two, you get 2,130,000 is equal to 130 times 5980 is 777,400 plus 225 VB. Rearranging this equation, you're going to get VB is equal to just algebra, all right? Move this to the other side. It will be 2130000 minus 777,400 divided by 225. Okay? Divided by 225. And this is going to be your VB value, which is 6,011.56 meters per second. All right? This is your value for your final value for the satellite. Okay, and obviously this is going to be larger than the initial velocity. Why? لأن if you notice here, this slowed down. معناته this has a reduction in momentum. Therefore, here it had to have an increase in momentum. So the velocity should have increased. This is the whole idea of conservation of momentum. هني قلت يعني initially it was at 6,000. So if this became a smaller value, that means this has to become a larger value. All right, this is the concept of conservation of momentum. The second way of solving this that I didn't go through, but I'll go very quickly, is what we have already done, is using the impulse momentum equation. All right, which is the equation over here, this equation 1. We have already even applied it, but we couldn't apply it earlier because we had two unknowns. In this case now, we have already found our time t. We have found our time t. We just need to find our VB. And we have all the remaining values. We have our force, we have our time, we have our MB, and we have our initial velocity. So if we just plug in all these values, our force now, remember, we are looking at it for VB system. Our force now is a positive 1,500. So we have 1500 times time, the time that we have calculated from our previous question, which is 1.73, is equal to the mass of B, which is 225, times VB, which is what we are trying to find, minus initial velocity of 6,000. All right. So simplifying this, you're going to get 1,500 times 1.73, which is 2,600, is going to be equal to 225 VB minus 600. Okay. So now we just solve for VB again. VB is equal to 2,600 plus 6,000 divided by 225. معناته VB, it should be the exact same answer that we have found earlier, which is definitely not the case. What did I do wrong here? دقيقة. Oh, I forgot to multiply this by 225. This isn't minus 6,000. نسيت التوزيعة. So 225 times 6,000, which is 135. So it's going to be 135,000. صح 1.35 million. Yes. So this is going to be plus over here 135,000 plus 2,600 divided by 225. You get VB is equal to 6011.56 meters per second. Same exact value. It's just two separate ways to solve. Then two separate ways of solving. Okay. Is this clear so far? Is this good? What did you get 53044? For this one, check your numbers because I double checked this multiple times. All right. So this is for part 2. Part 3, it says calculate the velocity of recession or the velocity of recession or your velocity of recession. Velocity part 3. Your velocity of recession. All right. This basically means your velocity of separation. Then this is all that this is. This is what this basically means. Velocity of recession is the velocity of separation. So معناته you're going to look at your after velocity and you're just going to subtract your VB minus VA. That's it. You're looking at the velocity of the separation that has occurred. So it is going to be VB minus VA, which is equal to 6011.56 minus 5980, which will be equal to 31.56 meters per second. And this is your velocity of recession. It is just the separation velocity of both, all right? Usually it is the larger one minus the smaller one. That's basically it. Why VB minus VA? Like I said, usually it's the larger one minus the smaller one. That's it. Usually, okay? That's how it is. Most of the time, what they do, most of the time in this case, where it is a combined case, they take the velocity of the piece that has been separated from the main piece. Yani that's why we do VB minus VA. لأن usually the smaller piece is going to have a larger velocity than the larger piece. Usually, all right? But the idea of the velocity of separation is, or the velocity of recession, is just seeing how far the smaller piece has flew compared to your larger piece. That's it. They want to compare your VB with your VA. So all you do is VB minus VA. تمام? And that's it for impulse and momentum. Someone said ممكن تعيد جزئية الزمن هذا. قصدك هني حق الامبulse momentum؟ يعني part 1 ولا part 2؟ إنزين. The equation we have for impulse momentum عندنا F times T is equal to M final velocity or the change of velocity final minus initial. حلو. فاحنا متى نقدر نستخدم هالايكويشن when we have an impulse or we will have a thrust force or something يعني we have a separation or we have an impact. So in this case we have to use it in the after situation. We cannot use it before. In the after situation we can use it. We can use it either for this one or we can use it for this one. تمام. If we write the two equations, it is simply F times T. If we use it for the satellite, it is MB, which is B, VB minus U, لأن the initial velocity for both cases are equal. تمام? Or we can use it for the second case, which is MA and VA minus initial velocity, which is the same for both. لأن the force is exactly the same force that is the impulse force. تمام? But in this equation, we do not have our VB value. ما عندنا value of the final velocity given to us. So we have two unknowns مجهولين اللي هم T and VB. In this equation معطينا ال VA. في السؤال معطينا ان ال VA يساوي 5980. فنقدر نطلع ال T من الايكويشن الثاني. عشان شي استخدمنا احنا الايكويشن الثاني. وبعدين طلعنا ال T by just putting in all the values وتحل. تمام؟ ويوم جينا للحل الثاني الحين طلعنا احنا التايم مال الامبولس طلعناه. فهني احنا لو نطلع الفيلوسيتي نقدر نستخدم نفسه اول equation لان الحين صار عندنا بس مجهول واحد اللي هو ال VB. تمام؟ مفهوم اخوي احمد؟ انزين. Okay. As soon as I'm done with the last question, which I'll do right now, this is going to be uploaded. Okay. So someone asked a question. There is a question they did VB minus VA. Hello. All right. Just so you know, in this case, remember our velocity. I forgot the color code what I used. I think it was like this. Our velocities are both in the positive directions. زين. Our velocities are both in our positive direction. فمعناته this is plus VB and this is plus VA. أو بما معناه يعني this is plus VA was 5980 and VB is 6011.56 plus. They're both in our positive assumed direction. This is why our velocity is just, this is the equation you will always use, VB minus VA. ولكن هني لأن they're both positive, that's why you're just going to plug them in as positive numbers. However, if the directions were opposite, let's say, then this is just example, just as an example, all right? Let's say that we have our velocity in this direction for one of them, and the velocity is in this direction. Let's say that this is 5 meters per second, and this is 7 meters per second, or make it 2 meters per second. It doesn't matter, all right? So what are you going to do here? And this is our VB, this is our VA. هني, if we assume that this is our positive direction, all right? We assume that this is our positive direction. When you do VB minus VA, or let me do it in the opposite directions عشان it matches the example you wanted to do. If they were going in this way and you're assuming this is your positive direction, VB now is negative 5 meters per second because it is going in the opposite direction of the value of the direction that we have assumed. زين? Therefore, when we do our recession now, it is going to be VB minus VA, which is minus 5 minus 2, or in this case, it's minus 7. زين? Or in the opposite way, if we had them opposite in the very beginning, معناته this was our positive value and this was our negative value, which is where this is going in that way and this is going in this way. معناته now our minus 2 is negative. So VB minus VA is going to be 5 minus 2, which is equal to a total of 7 meters per second. تمام? This is basically what it is when you're talking about recession velocity. It depends on the direction of your velocities and your assumed positive direction. Why are these in the same direction? Very simple. VB is in the same direction because when we found the value, it came out as a positive number. All right. So VB is in the same direction because the value we got was a positive value. If this was a negative value معناته VB is in the opposite direction. تمام. بس في هالحالة هني حصلنا VB as positive. في حالة في حالة وين؟ إيه حق U حق VA in the question it mentioned that the satellite هني the speed of the spacecraft falls 5980 meters per second. يعني خففت السرعة مو معناته غيرت الاتجاه بس خففت السرعة ولكن في نفس الاتجاه. That is why their velocities are both in the same direction. تمام؟ إنزين. Let us move on to the final question, which is our lifting question, or simple machine question. Very easy, very direct. You understood, right? The directions. You understood what I did with the directions and why the cases. صح؟ فهمت الحين ليش الدايركشنز هني وهناك أو فهمتي ليش الدايركشنز هني وهناك صح؟ It's clear for the impulse. Good, perfect. Now, this is a very easy question. This should be free marks in your exam, no matter in what type it comes. You just have to understand what they're asking for. Again, we just did this. An effort of 150 newtons, معناته our E1 is 150 newtons, all right? Is required to lift a load of 2.4, so W1 is 2.4 kilonewtons. معناته it is 2400 newtons. تمام? On this same machine, an effort of same machine, so E2 is 180 newtons, W2 is 3 kilonewtons, or in other words, 3000 newtons. All right. So by just looking at this without any additional information, you can find your MA and you can find your law of machine and plot it and everything with only this given. Let's keep on reading. Knowing that the distance moved by the load is, so SW, the distance moved by the load is 20 millimeters. Remember, you have to convert this into meters, so it is going to be 0.02 meters. And the distance moved by the effort, so SE, is equal to 60 centimeters. Again, you need to convert this into meters, which is 0.6 meters. Answer the following questions. So this is our given values. All right. Part A says find the law of machine. So law of machine is E is equal to AW plus B. معناته يساوي معناته we have to find our two equations. Let me make this a bit smaller over here on the side. So we need to find our two equations. So equation 1 using E1, which is 150, is equal to A times W1, which is 2400 A1, 2400 A plus B. Same thing again, we're going to apply this for the next set of values, E2 and W2. So 180, 3000 A plus B. Use mode 5.1. You're going to find a value for A, which is going to be equal to 0.05. And you're going to find the value for B, which is 30. Tamam? You can either use mode 5.1 or you can use simultaneous equations, right? You have two equations, two unknowns, and you will do that. And now once you find these values, you will plug them back into your equation, 0.05 W plus 30. Okay? This is for part A. Part B says draw the law of machine equation, effort on y-axis and load on x-axis. They even clarify the axis that you need to do. So the way you will draw this is so this is our x and y axis. Our y is going to be our E in newtons, and our x is going to be our W in newtons. You're going to be using the equation that we have found earlier to plot the points, all right? So the first thing you're going to notice in the equation is this 30. This is your y-intercept. شو يعني y-intercept? معناته it's a point on your y-axis, okay? Let's say that this is 30 over here actually at the bottom. زين. This is your 30. Y-intercept means يعني W equals 0 and Y, or in this case E, is equal to 30. All right, this is what your Y-intercept is. Okay, so the intersection of the Y-axis. And then the next point you're going to plot is you're going to take the smaller point between these two, اللي هو يعني the smaller values. In this case, it is 150 newtons. زين. So it doesn't matter. You can choose this one as well, but it is easier to plot the smaller value. For E1 is 150 newtons and W1 is 2400. So let's look at the E value first. It's the Y-axis. So this is 30. Let's say 150 is somewhere here. This is not to scale, but let's say 150 is over here. All right. And let's say that W1 is 2400 newtons. Fair. Let's say that, I don't know, this is 400. And then let's assume this is 400, 800, 1200, 1600, 2000, and 2400. All right. So assume, again, not to scale, just quickly, I'm drawing it. Let's say that this is 2400. All right. So at 2400, you're going to look at the point where it intersects with E1. Let's see, يعني هو هني. All right. So this is your point from 2400 and 1500. And then you're just going to draw your line of the curve from the 30 to that point, yani from these 2 points. You're going to draw a line through both. And this is your equation of the line. So the equation of this line is E is equal to 0.05 W plus 30. And you can mention that the slope is equal to 0.05. Remember, the slope is this value over here, which is your M. It is slope, or even your A value that we have found from earlier, which is this value, right? This is your slope value, all right? That's the value over here that we wrote down here, your slope. Tamam? And this is how you just draw it. Very simple. We've already went through this. Let's look at the next question. What load can be lifted with an effort of 200 newtons? So now in part C, they tell you that, let's first of all write our equation of and the law of machine. So it's 0.05 plus 30. So they say now an effort E3 is equal to 200 newtons, all right? What will be W3? This is what they're asking. What will be your load? What load can this effort carry? You're just going to plug it into the equation. So it's going to be 200 is equal to 0.05 times W3 plus 30. And then solve for W3. You're going to get 200 minus 30 over 0.05. معناته W3 is equal to 3,400 newtons. All right, that's basically it. That's how you would solve for such a question. Part D says calculate VR, your velocity ratio. Remember, your velocity ratio, very easy. It is just your height or your distance of your effort divided by the distance of your load. So SE over SW. Okay, SE and SW, let me copy paste these down here so you see them as well here while solving. So these are our values of SE and SW. Remember, you have to keep them in meters for both. So this is going to be 0.6 divided by 0.02, which is going to be equal to 30. Yes, 30. And that's it. There's no units, all right? Because it's a ratio. And this is your VR. So this VR is going to be constant for everything. Any type of question you need to use VR or efficiency, you will use the same VR value 30, all right? Because this is a fixed value for specific machine. So let's look at the next part, part E. Calculate the MA for an effort of 200 newtons. So MA then is going to be equal to mechanical availability then mechanical availability. Is it mechanical availability? I forgot what MA stands for. كل شوي قاعد أنسى. And then, but anyways, the value of MA is gonna be simply, they want you to calculate it for a specific load, or in this case, for a specific effort. And here they mentioned the effort of 200 newtons. معناته you need to find a mechanical advantage. Thank you so much. Mechanical advantage. To find your mechanical advantage, it is going to be your load over E. But you need to know which load divided by which effort. لأن your mechanical advantage varies depending on your load and effort. All right. So in this case, they said they wanted it for the 200 Newton effort, which we already have found over here. We found our W3. We called it 3. So let's call this W3 over E3. This is our advantage, mechanical advantage for 3. All right. So W3 is 3,400 newtons over our effort 3, which is 200 newtons. يعطينا إن mechanical advantage 3 is going to be equal to 17, and that's it. All right. And that's how you'll find this ratio. Let's look at part F. Part F is asking for the maximum mechanical advantage. Very simply, maximum mechanical advantage, so MA max is equal to 1 over the slope, all right, of your law of machine, or in other words, 1 over M or 1 over A. Okay, the slope is the value that we have found early on, which is over here, this 0.05, all right, this 0.05. معناته this is 1 over 0.05. So our MA, our max MA is going to be MA max is 20. زين. So the maximum value for your mechanical advantage will be 20. And يعني, if you found a value here that is smaller or the opposite way, just know that you made a mistake. لأن this is the maximum possible value that you find. All right. So now let's look at the next part, part G. It says find the efficiency when lifting the load the 3 kilonewton load, which is this load over here. زين. This is the 3 kilonewton load or 3000 Newton load. So they want us to find efficiency for this case. What do they mean by this case? So we know that this is part FG. So we know that efficiency is equal to mechanical advantage over velocity ratio. All right. Velocity ratio will not change. It's equal to 30 that we have found early, but the mechanical advantage will depending on your load. All right. So which mechanical advantage they want? They want the second one, or the one for this load, for load 2. معناته this is going to be W2 divided by E2 in the numerator all over your VR, which is a constant value that does not change. Okay, so this is going to be equal to W2 is 3000 divided by E2, which is 180, all over. You can calculate MA2 by itself. Yes, of course, multiply by 100. Thank you very much. I always forget the 100. Insane. Multiply by 100, multiply by 100, and then divided by our VR that we calculated early on, اللي هو 30. تمام? And that's it. You can calculate your mechanical advantage separately if it's easier for you. It's just the same thing. I just did it all in one step. So our efficiency 2, I'm going to call this efficiency 2 because we're talking about load 2. This is going to be, you just put all of this into the calculator and you're going to get 55.56%. All right. Now, let's look at the next question. H, it says find the maximum efficiency. Very simply, maximum efficiency means, so part H, you're going to find maximum efficiency, which is your MA max over VR. Remember, VR does not change for any specific system, but your MA will, depending on the load. And we have found our MA max, which is 20. So it's 20 again times 100 over 30 times 100. And that's it. So it is going to be 66.67%. This is your maximum possible efficiency in the system. All right. Now, the final part. The final part says also calculate the amount of effort lost. زين. It says lost effort. When they're talking about loss, they're talking about energy loss or work loss. Every time you read the word loss, معناته energy loss or work loss. In overcoming the friction. When lifting, for which one? For which case? For the 3 kilonewton case. All right? So for this case over here, E2 equal 180 and the workload is 3000 newtons. تمام? So this is part H, G, H, I, part I. زين. I forgot my alphabet for a second. زين المهم. So we need to find the work done. So we know that how much work is done, how much the loss is present. How can we find loss? So it's going to be work done of effort. We're going to find that. And we're going to find the work done of the load. And what is the equation of work done? It is the force. In the case of effort is E2, because we're looking at E2. And in this case over here, it's W2 times the working distance. And the working distance was already given to us in the question. It is a distance moved by the load is 20 millimeters. So for the load is SW, and for SE it is this distance over here. But just make sure that you are converting them into meters. So keep it in SI units. So this is going to be SE, and this is going to be times SW. And that's how you can find the work done, or the effort, for the effort and the work done by the load. So this is 180 times 0.6, which gives you 108 joules. And then you have your second one, which is your load, 3000 times your distance moved, which is 0.02, which is equal to 60 joules. Okay, so which is equal to 60 joules. So we found our work done, the effort from here, the work done due to effort, and the work done due to the load. الحين, what do you need to do? You need to do delta work done, the change of work done. So the work of the load minus, because this is your output, your final work of out minus work of in. So it's going to be work done by load minus work done by effort. Okay? In other words, it is 60 minus 108, which is negative 60 minus 108 minus 48, yes, minus 48 joules. This negative value shows you, remember, the reason we did workload minus work of effort is that load is our output. It is our final value that we are getting. And the effort is the input of our thing. So it's output minus input. That is the whole idea. All right. And when we get a negative value, معناته this is a loss. This indicates loss. So we can say our work loss due to friction, or our work done due to friction, is going to be 48 joules. And that is it for our session today, for our mock test as well. I hope you guys understood everything. I hope I wasn't going way too fast. إن شاء الله يعني توضحت المعلومات شوي.